Let us study uniform acceleration and non-uniform acceleration. Uniform acceleration means change in velocity equal in equal interval of time. Okay, here it is, change in velocity is equal for equal intervals of time. Uniform motion means change in velocity is equal. It means that it is acceleration, so change in velocity will be considered with respect to time, and here the change in velocity is equal in equal time interval. Okay, for example, you can say if it is 5 meter per second square. Okay, if the acceleration is 5 meter per second square, it means that 5 meter per second square is, sorry, the velocity is changing with 5 meter every second. It is increasing by, if it is positive, then it is increasing by 5 meter per second every second. The velocity is increasing. And here for non-uniform, just reverse it, change in velocity is not equal. Okay, in equal interval of time, just opposite of this. Okay, it means what? If here in uniform velocity, if the change in velocity is equal in equal interval of time, it means that it is a constant. Okay, here acceleration is constant. Okay, only in constant acceleration the change can be equal every time interval. Okay, here just reverse, acceleration is not constant. Now in uniform velocity, if the acceleration is not constant, it means what? It means acceleration is not a function of time, and here acceleration is not constant, so it is a function of time. It means what? Let us take one example. Okay, if acceleration is given as 5 meter per second square, and here acceleration is a function of time, let it be 5t this much meter per second square. Okay, this is non-uniform acceleration representation. It will be a function of time. Okay, this is a function of time. It means what? For t equals to 3 seconds, it will be 15. For t equals to 4 seconds, it will be 20. It means 3 acceleration will be 15. T equals to 4, acceleration will be 20. It is varying every time. Okay, one it is 15, another time it is 20, so it is not uniform. And here it is fixed. There is no t here, there is no t after 5, so it is at t equals to any time, 3 or 4 or 5 or 6, any time acceleration will be constant. Okay, acceleration will be 5 only. But here in non-uniform motion, acceleration is a function of time. It is changing every time. Okay, so it is non-uniform, therefore it is non-uniform. Okay, as we see, acceleration is not constant here in non-uniform. We see acceleration is not constant, it is changing. Once it is 15, once it is 20. Okay, after every change in time, acceleration is also changing. This is the real meaning of non-uniform acceleration. After every change in time interval, acceleration will also change. But here time is changing. It is first time it is 3 second, it is 4 seconds, and acceleration is constant. Acceleration remained constant. And here acceleration is what? Acceleration is variable acceleration. Here it is constant acceleration. This is also a point of difference. It is variable acceleration, it is constant acceleration. Okay, now in uniform acceleration, where acceleration remains constant, we know there are 3 equations of motions valid for this. Okay, so here 3 equations of motion. What are they? First one is v equals to u plus at. V equals to u plus at, first equation. V means final velocity, u means initial velocity, a is acceleration, t is time. Second equation is s equals to ut plus half at square. This is second equation. S means displacement, u initial velocity, t is time, half is constant. A is acceleration, t is time. And another one is what? V square equals to u square plus 2as. This is third equation. V final velocity, u initial velocity, a is acceleration, s is displacement. Okay, and here what is valid? Here generally it is when acceleration is not constant, the equations will, the problems, the numericals we will get in the question paper will not be solved using this. This formula is only for where there is uniform acceleration, means this formula will be applicable where acceleration is a constant. Acceleration is constant. For constant acceleration, these equations will be valid. And when acceleration is not constant, the equations valid will be generally two equations we can write. Okay, there are some extensions, somewhere it is written 3, somewhere 4, those are derived. Mainly there is only one, but we write 2, that is acceleration equals to dv by dt. This is the main. When acceleration is not constant, in numericals, when we will get one acceleration that is not constant, how will we recognize if the acceleration is not constant? We will recognize by looking at the t factor, this one. Looking at t present in acceleration, it means this is non-uniform acceleration. Here it is, acceleration will not be constant. We will apply this formula, not this. Okay, clear? Now another one we can say, for getting v will be equal to ds by dt. Okay, where s is displacement and v is velocity, you know. Okay, now let us see one example, one numerical, to understand it more clearly. If the question is, suppose that there is a question. Suppose that there is a question. The question is, if displacement equation is given as 4t square minus 15t plus 25. Okay. If displacement, it is displacement given as this one. Okay. And now it is, now we have to find acceleration equals to what at t equals to 0. Or 1 or 2, anything we can take. This is displacement is given as this one, displacement equation. Then how we will find acceleration? We know that a is equals to dv by dt. Okay, then velocity, we will at first need to find velocity, then we can find acceleration. So velocity is what we know here, ds by dt means dx by dt. That will be equal to what? When we will solve it, it will be 8t minus 15. Upon differentiation, we will get this one. When velocity is 80 minus 15, then what? Acceleration will be simply 8, because acceleration will be dv by dt. Okay, and that will be, on differentiate this, dv by dt, 80 minus 15, we will differentiate this. What value we will get? Simply 8. What happened now? It is only 8. There is no factor like t. Okay? There is nothing like t here. So this is constant acceleration. It means at time t or time any time, it will be 8. Okay, answer. If this timing would be even 2, even 4, or any timing, it will be 8, answer. Okay, because the acceleration is constant here. The acceleration would be 8t. Then it is, these t terms are useful. Okay, thank you.